Welcome to everyone. So today we'll have this talk about the life cycle environmental impacts related to alluvial gold mining in the Peruvian Amazon rainforest. My co-authors and part of the research team are Eduardo Parodi, Gustavo Larrea, Carlos Mesta, and Professor Vasquez. In recent decades, artisanal and small-scale gold mining has grown considerably, not only in Peru, but in countries in other parts of the globe, such as Ghana, French Guiana, Indonesia, and also in Latin America, such as in Brazil and Colombia and Venezuela. Alluvial gold mining is rampant in many areas of the Peruvian Amazon, and these images that you see are part of the Madre de Dios region, where in the recent years has created an enormous amount of deforestation in the area. Alluvial gold mining activities in Madre de Dios, part of the Peruvian Amazon rainforest, are responsible for mercury emissions and deforestation. Here you can see more photos related to these activities in the area. And in your right hand, you will see a really interesting figure that comes from a recent research article from Caballero and colleagues from the CINCIA research group that explains how these activities have increased over the years, in this case over the last 34 years. And you can see different areas where different start dates of the activities, and you can see in these circles areas with a major intensity of alluvial mining in the rainforest. The idea of this research project was to analyze the environmental impacts related to alluvial mining in Madre de Dios. We use life cycle assessment as the main methodology. We used USTOX and IPCC 2013 to understand the environmental impacts of these activities with regards to human toxicity, freshwater, ecotoxicity, and climate change. Our functional unit was 1 kilogram of gold ready for sale. And something that is important to mention now is the different strategies that were used to develop this life cycle inventory. And it's important to mention because the conditions of the system and the difficulties that are related to these activities made us decide to have different strategies such as interviews, field studies, and the modeling of these extract systems in our outside the field in Lima. So we had different strategies. It's not easy to go there and ask the type of questions that we wanted to ask, mainly because of all the pressure from the government with regards to these activities in the Peruvian Amazon. We'll talk more about that soon. This is the study area, and you can see that we landed in Puerto Maldonado in the second and third field studies. And in the first one, we went from Cusco by land to the area of Huaypetue and Mazuco. Important to understand that aside from Huaypetue and Mazuco, we studied mining activities in Rosario de Laberinto and throughout the river, that is the river Madre de Dios. Okay? We didn't study mining activities in illegal areas that are related to the Tambopata National Reserve and the Baguaja-Sonene National Park, mainly because of our safety when performing this research project. Important to mention that long time ago, the government selected some areas for mining activities, and no surprise that long time ago, this promotion of mining activities in the Peruvian Amazon, in a way, increased mining activities there in the area and were partially responsible of what we see today. Important to note that when talking about alluvial mining in the Peruvian Amazon rainforest, we have different extraction systems, and we model 4 extraction systems. The names or local names in Peru are the Carretilla, Canaleta, Ingenio, Chupadera, Traca, Carranchera, Draga, and Chute. I will explain them soon. Important to note that the idea of modeling these extraction systems was to understand the different processes and to relate those with the different environmental impacts that are related or should be related to each extraction system. When we model the extraction systems, we had a lot of things in mind, and the classification was mainly related to deforestation that was related to this extraction system, and the tools or equipment that was used in order to get gold from this system. So the first extraction system is a system that we classified as one that has a minimum deforestation and a low production and mostly the use of manual tools. For the second one, we have a high deforestation, medium production, and is part of this, of what some authors call the mud suction extraction systems. The third extraction system is the one that is actually has the activities inside the river, in the river beds, and also has as a method to extract soil, the suction method. And then the fourth extraction system is a medium, has a medium to high deforestation, and here the production rate is really high, and the use of equipment and machinery is important. So when if we want to model or understand what systems are part of these 4, you can see that the drainages are part of the type 3. Then you can see them here. This is one of it's kind of a typical moving, floating industrial system for alluvial mining. This is the drainage, similar in a lot of parts of the world. And here, in type 4, you can see what we call the chute. So you have an intensive use of machinery for soil removal. And this is an example of what we call the carretilla, or a type 1 extraction system. Here are other examples of what we call the type 2. And in this first image, the one that is in the left upper side of the screen, you can see what we call the chupadera traca. This is a suction type extraction system, where one thing I want you to notice is that also in this picture, what we had before was a forest, and there is a lot of deforestation that needs to be done in order to have this open pit that is the one you see in the upper side of the screen, okay? And at the bottom, these are the type 3 type of systems that are in a way part of this. One of them is the dredges, and the other ones are the ones that work on this riverbed. When talking about life cycle assessment, it's important to understand the system boundaries. So this is a figure that represents the system boundaries. I will start with what happens on site. So we have a forest slash or burning, soil removal. We have pumping of water, that is very important in order to finally get the gold concentration. So we get the gold concentration, and then we have the use of mercury for the amalgamation process, and then the amalgam roasting that concludes with the gold that we want to get, and the one that is part of this functional unit for this LCA. Important to know that after this first roasting, we have the miners transport this gold to what we call gold shops that are part of this local market. And in these local, in these gold shops, there is a second amalgam roasting that is performed. For our analysis, this final roasting is included in our system boundaries. And what happens in the supply chain? Everything that is required by these activities is what we include in these supply chains, and this part of the life cycle inventory. We rely on secondary data from EcoInvent mainly to perform this LCI. Important to know that we have a lot of different types of processes in these mining activities. It's important to understand that the size of these mining sites, it will depend on a lot of factors. It's not like going to Foxconn and understanding or having a nice industrial setting for, in that case, the manufacturing of computers. In this case, we have very unique type of industrial settings with regards to the extraction of gold in this area of Peru. And we have people that manage the processes, and there are people that are starting these activities. So the difference between processes in each part of Madre de Dios is really big. So what we tried to do was trying to work with ranges, okay? And in this table 2 of the paper that I can send you, or I can show you later, is what we understand as minimum, maximum, and typical values, okay? Today I will mostly show you the typical values because the results I will show you are mainly from typical values, but important to know that we also model scenarios that consider minimum and maximum values. For example, when talking about gold extraction yields, we use 0.3 grams per cubic meter of soil. However, values can range from 0.1 to 1, okay? Then another thing that is really difficult to get from the field is the mercury to gold ratios. And this, as you know, mercury and the amalgamation are the main techniques used to recover gold. So these range from 1 to 5 grams of mercury per gram of gold. And in our analysis, we use, when talking about average results, we use 2. Another thing that is important to note, and I will explain later too, is that there is a use of retort. In a way, retort is a technique that can be used to recover mercury from the roasting of the amalgam. However, the use of retorts has not been well received from all the miners, so the adoption is low, okay? And if you adopt this technique, we assume that the recovery rate was around 90%. However, based on different authors, it can range from 75 to 95%. Another thing that is important to note from this table is the deforestation and the emissions related to deforestation. Based on our environmental agency and based on the real conditions of the forest in Madre de Dios, we used 510 tons of carbon dioxide equivalent per hectare of forest. Okay, so the bottom line from this, or the most important message from this table, is that although the results I will show today are mostly taken from the typical values, the range is an important thing to consider and has been also modeled. When creating the life cycle inventory, aside from table 2, it's important to understand that we have other parameters that are also important. One of them is the system gold yield, and this will vary a lot from extraction system to extraction system, as I explained before. So when talking about the manual process of carretilla, that is a type 1 system, we're talking about 3.6 grams per day. However, if we talk about activities like the chute, we are talking about 162 or 51 grams per day. Okay? Then we have a heavy use of machines in the extraction systems that are the type 4. Pumping systems are used in all the extraction systems, 1, 2, 3, and 4. And then there are other materials that are important to understand and measure in order to perform this life cycle assessment. Okay? So now let's go and see some of the results. When talking about human toxicity, it's important to note that the values are governed by mercury emissions in gold recovery activities. Around 80% of these impacts are related to the amalgamation and amalgam roasting. However, if we start using the retort, and this is a scenario B, where we have a recovery of mercury around 90%, the activity itself that is related to the amalgamation and the amalgam roasting is not as important as the human toxicity impacts related to the production of mercury. Okay? Something that is really interesting to see is that there is a third option that we call a scenario C. And this scenario C is the use of gravitational tables to obtain gold without the use of mercury. And that's something that is already being used by a small amount of miners, but the good thing is that it's being used. So in that scenario, the main processes with regards to human toxicity are the use of machines and the natural stock of mercury that is removed when we start removing the soil to get this gold concentration. So important to note that natural stock of mercury could be relevant in some cases. Okay, so we have 3 scenarios, and these are the results for the 3 scenarios when talking about human toxicity, cancer, and non-cancer. Okay, when talking about freshwater ecotoxicity, machines and diesel use for ore extraction and freighting activities drive freshwater ecotoxicity, as you can see in this figure. Heavy duty machines and fossil fuels. Okay? And when talking about deforestation, the average results will tell us that, when talking about climate change, the average results will tell us that deforestation is a very important factor affecting climate change. Also, the use of fossil fuels and everything related to the heavy-duty machines. Something that I didn't mention before, it's important to note that when talking about numbers, if, for example, a scenario A with regards to human toxicity represents 100, we're talking about an impact of 10 times less in a scenario B and 100 times less in a scenario C. So there's a big change with regards to human toxicity when we compare these three scenarios. When talking about deforestation, as I told you before, it has a major contribution on the environmental impacts related to climate change. However, these impacts are dependent on the type of extraction system. And this is something that is really interesting because although it's evident, it's not something that is being considered by policymakers. Why? Because, for example, the main system that relates to type 2 system is the one that has the higher amount of tons of carbon dioxide equivalent per kilogram of gold extraction. However, the dredge that has the lower impact is the only extraction system that is banned. So it's interesting to see how, although Peru is pursuing everything related to reduction of greenhouse gas emissions and is really working on everything related to the Paris Agreement, some policies are not thinking about how important is the impact of deforestation in some extraction mining systems. Okay? To try to understand the order of magnitudes, I present this figure, and this is related to the LCA relative impacts between system extraction processes and mercury emissions. Okay? So here, what I want to show is that in the average results, the impact of the use of mercury is important. However, in some cases, natural stock of mercury and the release of this natural mercury could be also important. Okay? And when we start using retorts or gravimetric tables, mercury will still be a problem, mainly because of the natural stock of mercury in those areas. Okay? Numbers into perspective. Average results show us that we are emitting 31,000 kilograms of carbon dioxide equivalent per kilogram of gold. If we compare these results to, for example, this mine, and this is mainly a data that I got from CIMAPRO, and this is a process from EcoInvent, you can see that here they are talking around 17,000. So clearly deforestation related to these activities is important, and the values related to gold in Madre Dios are also important. And if you compare that to Portland cement or copper or a laptop, you can see that the difference is really, really high. Conclusions. Clearly, the environmental impacts of gold mining in the Amazon have been analyzed using life cycle assessment. We used use-tox to understand toxicity and IPCC 2013 to understand the climate change. Over 80% of human toxicity is linked to mercury emissions in gold recovery activities, mainly the use of mercury for the amalgamation and amalgam roasting processes, the use of retort and gravimetric tables considerably reduce human toxicity impacts, and deforestation in mining activities has a major contribution to climate change. However, it's important to note that there's an inherent complexity that we can find in every socio-technological system that demands a careful attention of all the affected dimensions. When talking about Madre de Dios and alluvial mining in Madre de Dios, we are not only talking about environmental impacts that, yes, are extremely important. But if we only focus on these environmental impacts and try to solve this big problem, only thinking about environmental impacts, we will never solve the problems because there are important socio-economic, cultural, institutional dimensions that will influence and that already influence the system. I don't know if you have heard, but in Madre de Dios, we have a lot of human trafficking, sex exploitation, laundering, exploitation of minors, malnutrition, organized crime, insecurity that are linked in many cases to these activities. Also important to note that there is a lack of opportunities, a lack of employment opportunities in the Peruvian Andes, and most of the people that work in these mining activities in Madre de Dios are people that come from the highlands of Peru. To finish, I want to acknowledge PUCP for funding this project, Concitec for partial funding of this project too, and different people that help us, such as José Carlos Bustamante, Gabriela Raran, Franz Cabanillas, and Francisco Roman. We have a paper that somehow I can at least share the link, and I want to show you real quick underwork, and that I will want to show you real quick.
Las nevadas de los Andes han sido y son destino de lluvias que durante miles de años han erosionado sus empinadas montañas y acarrean en su torrentoso regreso el oro escondido en ello. Estos finalmente, al llegar a los calmos ríos mediándricos de la llanura amazónica, distribuyen el preciado metal en todos sus suelos, los mismos que, en nuestros días, también albergan toda la riqueza natural de la selva húmeda. Llegar a las zonas donde se realiza esta actividad no es tarea fácil. Se requiere de un vuelo de 1 hora de duración desde la ciudad de Lima hasta Puerto Maldonado, capital del departamento de Madre de Dios, y muchas horas de navegación para llegar a los rincones más alejados de la selva.
El objetivo de este proyecto de investigación es entender los impactos ambientales de la minería aluvial en Madre de Dios.
El análisis del ciclo de vida es una herramienta de gestión ambiental que está estandarizada a través de la normativa ISO internacional. Dicha metodología consiste en analizar los productos, servicios o procesos correspondientes a través de toda su cadena de suministro, desde que se extraen las materias primas hasta la disposición final de los residuos de dicho producto o su recuperación para que se convierta en un nuevo producto. En este contexto es importante entender que lo que se va haciendo es en las distintas etapas del proceso productivo se van midiendo los flujos de material y energía, y posteriormente estos flujos se convierten en impacto ambiental. El impacto ambiental debe ser entendido como distintos compartimentos en los que podemos generar un daño ambiental, a distintas esferas del planeta, que puede ser al aire, al suelo o al agua.
En este estudio nos enfocamos en 2 categorías de impacto: cambio climático y toxicidad humana.
Para calentamiento global utilizamos las herramientas
de manera las emisiones de mercurio en Madre de Dios no solo se limitan al mercurio utilizado en el mercado. La actividad minera en Madre de Dios es también responsable por la liberación del mercurio naturalmente contenida en los suelos donde se realiza esta actividad. En algunas circunstancias, el mercurio naturalmente contenido en los suelos y luego liberado podría llegar a ser tanto o más importante que el mercurio vertido por la actividad.
En lo que refiere a la categoría de potencial de cambio climático,
Okay, so I can send you a link of the video when it's ready. And again, thank you very much for your attention. I'm happy to answer any questions that you may have.
Thank you so much, Ramzy. What an interesting study you have done, and heartbreaking to see some of the deforestation and what's happening in the area, but nice to know that there are people that are paying attention like you and your colleagues. If you might want to leave that slide up that says thanks, or how people can contact you while we have the questions, because I do have some questions from people. One says, how does gold mining affect the income and health of the people near the mines?
Yeah, that's a really important question. There is an important health problem related to the use of mercury, okay? And with regards to the miners, okay, clearly there is a health impact related to the activity itself, okay? And that's something, and that's why in a way, retorts have been promoted, and however, success was not there, because the adoption of retort has been very low. Okay.
And the reason that the retort the adoption of the retort is so low is because, is there a reason?
Yeah, that's a very important question. As like, remember that these miners are in most of the cases are people that they start the activities and they are not constant with those activities, and then somehow when using the retort they don't think it's useful. Okay. Mm-hmm. I think the most important one is the capability to use in an adequate way the retort and get the results that we are supposed to get from this. This.
So another person asked, did you consider the direct exposure of workers to the mercury and the mining and the refining residue? Maybe
no. So we're talking about like human toxicity. We mainly focus on regional and global impacts, okay? And however, certainly is important, and that's something that has been studied, luckily, but the results I show you are mostly related to the transportation and fate of mercury and impacts more on a regional and global scale.
Yeah, okay. Ramzy, have you looked into how gold mining in Peru compares with gold mining elsewhere?
Yes, we have compared. So there are a lot of things that are similar and different at the same time. Mm-hmm. So we have studied the cases in, for example, Colombia, in Antioquia, and in some cases, for example, there's no use of mercury, but in the cases that you have the use of mercury, some problems are related. Most of the problems, as usual, are related to the roasting of the amalgam. So in Antioquia, for example, I was mentioning the case where because of different reasons, one of them is related to the FARCs. The processing is being done in some urban areas of Antioquia, and the contamination related to mercury is really high in those areas. So in Colombia, there is a lot of reforestation of some areas, okay? In Peru, also in Madre de Dios, there's a group working on reforestation, okay? And not all artisanal and small mining activities share the same processes, mainly because of the type of ore that or the type of gold that you find there, okay? So in Peru, we also have these artisanal and small-scale mining activities in other areas where the gold is finding in different types of, you will say, formations, if you can use that word, and the processes will clearly change. Okay.
Mm-hmm. Someone asks, have these study results been received by the miners or the government officials?
It's not easy. It was difficult to contact them, so we got contact of them, but it's not that they want to give us their phones or emails.
Yeah, I can imagine.
Yeah, but the paper is already in hands of the government and government officials, and also some miners associations. Okay, so we have been part of several workshops organized by other members of the university, and yes, in a way, this has been this is it's a process that already started, but still there are a lot of things to do.
Yeah, and someone asked whether thought your study was very interesting, and whether if you may have compared or will compare or have compared the study of alluvial mining to a form of industrial gold recovery, such as in electronic waste recycling.
That's a really good question, and something that we might want to do. The only comparison with numbers is the one I showed you before. So yeah, when we put these into numbers into perspective, that's the first comparison that we did. But clearly there are a lot of things that we can do and show. But it's a good idea, really. It's a good idea because in some areas of the world, the use of mercury to recover gold is being done. Mm-hmm. And obviously you have other elements that you can use, but mercury has been used, for example, in India with regards to recovery of gold from e-waste. So that is really interesting to do.
Oh, Ramzy, what has been the role of the government in the alluvial mining system?
Yeah, that's something that we discuss in the paper, and it's really interesting to start thinking about this, is that the typical command and control strategy has been used and clearly has not worked. Okay, in the last, for example, year, there's one strategy that is related to what I said before that is supposed to be working, that the military went inside an illegal mining area, that is La Pampa. The Mercury operation is the name of this operation or strategy, and clearly in that area there's no mining activities because the military is already there and has been there for a lot of weeks already. So obviously performing this type of strategies all around the area is not going to be possible. And another thing that is important to understand is that these miners some of them will probably go back to their origins, highlands maybe, but some of them will start doing these activities elsewhere in Madre Dios. So what I'm trying to say is that although the government wants to reduce these mining activities, especially illegal activities, and in a way wants to formalize the informal miners, it still has not been successful.
Mm-hmm. What are the triggers that are related to the expansion of alluvial mining in Madre de Dios?
The triggers related to expansion, yes. The price of gold is one of them. Mm-hmm. And it's interesting to see how, for example, the highways, the new highways, like, for example, the Interoceánica, have been one of the main triggers because access to these areas is easy now. It's still difficult, but it's easier than before. So in this case, a highway has been a very important trigger to this accelerating activity in the area, mining activity in the area.
And probably accelerating more other activities that you don't really want to have accelerated.
Yes. And it's really sad to see And although I clearly think that these are important environmental impacts, there are other social, economical aspects that need to be considered before creating this solution to this problem.
Okay. Well, thank you so much for this interesting study. And for people who have missed it, we will be posting it on our website, and you'll be able to forward this, Ramzy, to everybody else.
Okay, perfect. Thank you very much, Holly.
So thank you so much for all your hard work, and continue to make this information available to everybody.
Thank you very much.
All right. All right. Bye-bye now.